Hello friends, and welcome to the final and the last session of forced vibration, in which we'll be seeing two numericals and covering up all the remaining part of the following chapter, in which you have to find out amplitude, force transmitted, zeta, c, damping, delta, everything will be covered in these two numericals, and you will be super happy that these numericals are very easy for solving in the examination with proper practice. Let's see what it is all about. Now, from this you know what is the mass is given. For your surprise, two masses are given. E is given, that is 0.1 mm, N is given 1500 rpm, and static deflection, that is 1 into 10 raised to minus 3 meter. Now this static deflection is different from logarithmic decrement. These are two very different terms. E was given in mm, you convert it into meter, that is 0.1 into 10 raised to minus 3 meter. Mass and mass are given. So you have to find out x, that is amplitude, when zeta is equal to 0 and zeta is equal to 0.1, and you have to find out force transmitted when zeta is equal to 0 and zeta is equal to 0.1. Let's see the first case when x and ft is to be found out and zeta is equal to 0. From the given data where n is provided, you can easily find out omega, that is the normal omega, 2 pi n upon 60. You get it as 157.07 rad per second. Now you have to find out k. For that k, two masses are given, which one to select. Always remember, the smaller mass is always considered for the force generated, F0, and the larger mass is used everywhere for calculation. So k is equal to W upon static deflection. Now if I may ask you to define what is stiffness, it is basically the weight attached to the spring and how much it pulls or deflects the spring, that will be stiffness. So weight divided by static deflection is stiffness, how stiff or how resilient the spring is to hold the weight for a longer time. That is basically W upon static deflection. So again, W is equal to mg, because we need W in Newton, as the unit of k is Newton per meter. So Newton will be mass into gravitational force, so m into g upon delta st, that is static deflection, which is equal to 25 into 9.81 divided by 1 into 10 raised to minus 3 meter. Answer will be 245.2 into 10 raised to 3 Newton per meter. So you now have stiffness. You can easily calculate omega n, which is equal to under root k upon m. So 245.2 into 10 raised to 3 divided by 25, which is equal to 99 radian per second. You can easily find out R now, omega upon omega n, which is 1.5859. And now the second mass which was given and the eccentricity which was given are now to be used to find out F0, which is equal to me omega square. M is the smaller mass, E is eccentricity, and omega was 157.07. You get an answer for F0, that is 12.3370 Newton. Next, you can find out this term by 1 upon under root 1 minus r square whole bracket square plus 2 zeta r whole bracket square, which is equal to 1 upon 1 minus, as zeta is 0, we are taking the first case, only this particular term will be left, so 1 minus r square whole bracket square. So this term becomes 0.66. Now the amplitude is F0 upon k into this particular term 0.66. Putting all the values, you have F0, you have k. F0 we have found out 12.33, k was found out by us, and now this term is 0.66, so you get an amplitude of 3 into 10 raised to minus 5 meter. Amplitude is always in meter. No values are to be taken in mm. All the values in meter and Newton. Also we have to find out the force transmitted. Now what is this force transmitted? For example, if a particular machine is generating 100 newtons of force, when it is in operation, it will be transmitting some force to the ground or the base or the foundation, whatever you call it. That is known as the force transmitted. The formula is Ft upon F0, that is transmitted upon generated, is equal to the particular term into 1 minus 2 zeta r square whole bracket square. You have all the values, you have F0, you have this particular term, you have 1 minus 2 zeta is 0, so this term gets cancelled. So only remaining term will be this one, so you can easily find out Ft is equal to 8.1424 Newton. The first case is done when zeta was 0. We have to again find out Ft, that is force transmitted, and x when zeta is equal to 0.1. It is pretty simple. You have all the terms. You have F0 from the previous answers, K from the previous answers. Only this term will be changing. So putting 0.1 in this place and you can find out 0.646. In the previous one it was 0.66, so there will be minute difference in the answers. You can find out x is equal to 3.24 meter. Next will be the transmission of the force, that is Ft. You can again find out, you have found out this term 0.646, and here you have to put 0.1 because it was 0, so this term got cancelled in the last case. Putting all the answers, you get Ft is equal to 7.5582 Newton. So this is all about the forced vibration, in which you have found out the transmissibility of force and the amplitude from the given data. No variety is provided in these types of numerical, and there are basically 4 types of numerical in forced vibration. Do practice them all very nicely, and I hope to see you in my next video. I'll be uploading the last session, that is the sine wave and the amplitude numericals, in which you have to find out critical speed as well as the time and some other factors we'll be seeing. So I hope to see you in my next video. Stay tuned.